we are discussing about the mole concept. In the last lecture, we had solved some numericals based on the mole concept. Now, we will solve a few more numericals and we will start with percentage composition. So, let's start. So, the next question is calculate the number of hydrogen atoms present in 25.6 grams of sucrose. Sucrose is C12H22O11, which has a molar mass of 342.3 grams. Okay. So, calculate the number of hydrogen atoms present in 25.6 grams of sucrose, which has a molar mass of this. Okay. So, 342.3 grams of sucrose is equal to 1 mole of sucrose, right? So, 1 gram of sucrose is equal to 1 by 342.3 moles. So, 25.6 grams of sucrose will be equal to 25.6 grams divided by 342.3 grams. This comes as 0.0748 moles. Okay. Now, in the formula of sucrose, there is H22, that is, one molecule of sucrose has 22 atoms of hydrogen. Okay. So, one molecule of sucrose contains 22 atoms of hydrogen. So, how many molecules are there in these many moles? So, 1 mole is equal to 6.022 into 10 to the power 23 molecules of sucrose. So, 0.0748 moles is equal to 6.022 into 10 to the power 23 into 0.0748 molecules. Okay. This comes as 4.504 into 10 to the power 22 molecules. So, 1 molecule of sucrose contains 22 atoms of hydrogen. So, 4.504 into 10 to the power 22 molecules of sucrose will contain 22 into this. This comes as 9.9088 into 10 to the power 23 atoms of hydrogen. So, we have solved many numericals on the mole concept. Now, we will discuss about the percentage composition. So what is the percentage composition? See, till now we were talking only about the number of particles or number of moles or amount of substance. Okay. Now let's say there is a molecule. The molecule is made up of a lot of atoms. So we also need to know what is the percentage of each element in that molecule. Or sometimes we want to check the percentage of elements in a given sample with the percentage of elements present in the molecule of a pure substance. So for this purpose, we need something called percentage composition, by which we can determine the amount of elements present in a molecule of a compound in terms of percentage. So now we will study about the percentage composition. Percentage composition, okay. So, the definition of percentage composition is percentage composition is the percentage by mass of each element in a compound. Okay. Let's say we have H2O and H2O2. We have CO and CO2. We have methane and ethane. We need to find out the percentages of each element in these compounds. So what will be the formula? So percentage composition can be calculated as mass percent of an element is equal to mass of that element divided by molar mass of the compound into 100. Okay. So, mass percent of an element is equal to mass of that element by molar mass of the compound into 100. Percentage composition can also be expressed as number of atoms of that element multiplied with atomic mass. Okay, we have to multiply with the atomic mass of the element divided by molar mass of the molecule into 100. Okay, this is also the formula of percentage composition. Let's say we have a molecule AXBY. Okay, so let's say the molar mass of AXBY is equal to M AXBY. Okay. Molar mass of A is MA and molar mass of B is MB. Okay. So, we can say that the percentage of A in AXBY. So, here if we the mass of the element, okay, mass of the element will mean the molar mass of that element multiplied to the number of atoms of that element which is present in the compound, right? So, in AXBY, the number of A atoms in AXBY is X and number of B atoms in AXBY is Y, right? So, percentage of A in AXBY is X, that is number of A atoms, into molar mass of A, that is Ma, divided by the total mass of the compound, that is molar mass of the compound, which is MAXBY. Okay. So, this is the percentage of A. Now, percentage of B in AXBY. This will be equal to the number of B, that is Y, into the molar mass of B, which is MB, divided by M of AXBY. Okay. So, this is the percentage of B in AXBY. Now, let's do some examples. Okay. Let's start with some simple examples. So, we have to calculate the percentage composition of water. Okay. So, molar mass of water, or we can also say this is the molecular mass of water. This is equal to 2 into 1, that is 1 is the atomic mass of hydrogen, plus 1 into 16. So, 18 grams. Okay. So, percentage of hydrogen in water. This will be equal to number of hydrogen into atomic mass of hydrogen divided by molecular mass of water multiplied with 100. So, this is 2 into 1 divided by 18 into 100. So, this comes as 11.11%. This was the percentage of hydrogen. Now, percentage of oxygen in water. This will be equal to, again, the number of oxygen into the atomic mass of oxygen divided by the molecular mass of water. into 100. Okay. So, this is equal to 1 into 16 divided by 18 into 100. So, this comes as 88.88%. Now, let's see another simple example. Percentage composition of carbon dioxide. Okay. So, what is the molar mass or molecular mass of CO2? 12 into 1 plus 16 into 2. So, this comes as 44 grams. Okay. So, now percentage of carbon will be equal to the number of carbon into atomic mass of carbon divided by molecular mass of CO2 into 100. So, this will come as 1 into 12 by 44 into 100, which comes as 27.27%. Then the percentage of oxygen, this will be equal to again the number of oxygen, that is 2, into the atomic mass of oxygen, which is 16, divided by the molecular mass of carbon dioxide, which is 44. This comes as 72.73%. Okay. Now, similarly, if we calculate with carbon monoxide, then it will be, in that case, the percentage of carbon will be 1 into 12 divided by 44 into 100. This will come as 42.8%, and the percentage of oxygen will be 16 into 1 by 44 into 100. This will be 57.1%. So, we have studied about the percentage composition and we have done some simple examples. In the next lecture, we will do some more examples on percentage composition and we will start empirical formula and molecular formula. Thank you.